6/9 now. Didn't make any mistakes there, did we? Hey folks, welcome, and welcome out there to TN Learn Mathline. Summer school's time, all right? It's summer school style, that's what we're doing. Remedial, and I'm Ernie Roberts, and I am your host for this afternoon session. Now, this is one of those days where I want to say, I don't think you need pencil, but hope you'll be listening and hope you'll be answering quick. There's a lot of mental math going on today, all right? As we continue our study of the multiplication tables, and let's see what the topic of the day is for us here. We've been back to the basics. Now we're going to look at cheaper by the dozen. You've heard that expression, if you buy a dozen, well, that's 12, right? So today it's all about the 12s. It's all about the 12s. And that's what we're looking for, those times tables. Some of those are a little bit more difficult, but you know, if you get through their 5s, the 6s, the 7s, and on up there, those aren't so bad, all right? You can work those through, do a little mental math, all right? Let's see what we got going today. We're going to look, first of all, what kind of facts are we looking at? So let's take a look at the 12s. Let's take a look at these, all right? And there are 6 that I want to look at. Notice I left out 10. You say 10, what do you mean? I left out 10 times 12 because that's easy. You've got that down. We learned the 10s. 10 times 12 is 120. Just put a 12, add a 0 when you multiply by 10, all right? So we're looking at the numbers that maybe give us a little more difficulty. That's what this show's been about. I want you to realize some things you do know. You don't need to worry about those. You'll remember those. Review them occasionally, and you remember them again. But there's some of them that we struggle with, all right? Some of my students do, and some of you guys are in 3rd, 4th, 5th, 6th, all the way up through those years grade-wise. And you adults, it's a good time to refresh your memory also, all right? So let's talk about it. 6 times 12. Now, so many times we think of ourselves, someone who's 6 feet tall, well, there you are. 6 times 12, how many inches does that make? Well, it makes 72. And that is one basic number right there. Guys, 6 foot is a pretty normal height. Maybe not exactly average, but there are quite a few people out there 6 feet and beyond. So it's a good benchmark right there, 72, and that's what we get when we take 6 times 12. Now, let's bump up another 12. Now, you've got 72. You can add 12 onto that 72, make the next one happen. Quick mental math. And or you can just learn the fact. The fact is 84. It's 12 more than the one we had previously, all right? So we went from, again, 72 at 6 times 12. We move forward one more 12, all right? Add 12 to it. It's going forward. And we have 84 there. Now, I've got 11 times 12. Let's bump that for just a minute. Let's go down here and hit 8 times 12 since we're kind of working in an order here. So let's do that. 8 times 12, it's 12 more than 84, right? Because that was 7. What 7 12s give us? This is now 8 12s. You could add the 12 up 8 times, or you can just learn the fact. I think it's easier to learn the fact when we get these big numbers like this. So 8 times 12, I said it's 12 more than 84, so how about it? Let's move it up to 96. There you have it. And not to be left out, there's 9 times 12. Now we're over 100, and some people get freaked out over those, all right? Don't do it. It's not that difficult. It's just 8 over 100, all right, which is going to give us 108. In other words, we went up 8 beyond 100 because when we add 12 to 96, there you are. Now, remember a minute ago I said 12 times 10 is going to give us 120? We don't need to worry about that. That's easy. You can do that mentally immediately. Now, let's bump on up from 120 over here to, 11 times 12. What do we do with it? We got another 12 in there, my friends. We add a number 12, and that's going to make us up to 132. And last but not least, I think 12 times 12 is a great number because it's 12 squared. Loves when we square numbers. It's great for you to know perfect squares when you get to geometry, you get to algebra 1. If you've got those on the top of your head, man, it helps you out so much there. So that's why we focus on them right now. And 12 times 12, we come up with 144. 144. Wow. And if you're really getting interested in this stuff, that's 12 dozen. That's 12 dozen, all right? Because remember, 12's a dozen, cheaper by the dozen. So there we have 12 dozen. That actually gives us 144 items, whatever those happen to mean. Maybe they're eggs. Oh, maybe they're just pieces of string. Who knows? All right, pieces of string. I don't know where that came from either. But anyway, we buy a lot of things by dozens, and we call those gross when we get to 144. How about that? A little known fact, here you get it on Mathline, all right? Now, those are the numbers we're going to play with. So again, I want you to think those through, and let's start getting those into your head, because we're going to practice them in the show, all right? That's what this is all about. Practice, practice, practice to where you know them by heart when you get through the next, let's say 20 minutes, all right? So spend a little bit of time with me now, and be going like, hey, I know my 12s. I know my 12s really easily, all right? So let's take a look at our first situation here. Let's take a look at what is the product of, it says, 9/10 and 12/100. Wow, that's a good bit of numbers there, you know. But first of all, we know 12 times 9. Now 12 times 9, dear friends, you got it, right? It's going to give us 108. So we put our 108 right down there. There we go, right there it is. Now, the question is, what do I do with these decimal points? All right, it's just decimals, multiplication. You count how many places to the right. Well, we've got one place here, and we've got two more here. So we need to move our decimal in 1, 2, and 3 places. There it is, all the way to the front, all the way to the front. So we've got 108 thousandths, all right? Whew, that's a little more than 1/10, all right? And by the way, that is just what it says. The decimal and then your 108 follows right after it, all right? Follows right after it. Now let's take a look at our next little problem. Next problem is basically all about what is 12 times 8. 12 times 8. Well, we know that 12 times 9 is 108. Hopefully you've got 12 times 8 under your belt, so to speak. You've got it down pat. It's going to give us 96. It's going to give us 96. Now, again, remember that decimal's hanging out at the end until we move it. Well, how many places are we going to move it, my friends? We've got 1, and we got 1 more. That is 2 places to move. So here we go. 1, 2. Pop it right in there. 96. This time, hundredths. It'll be hundredths. Now, just a what if, all right? Just a what if with you, all right? I like doing that. You know that by now. Let's see if I had put the decimal in front of the 12, all right? I would have 3 places to count off. And notice what I would have needed. I would have needed an extra place. Put a 0 in there. When you have an open slot, zeros are wonderful, wonderful digits to fill in the missing space, all right? Put something in there and doesn't affect the value of your answer. But in this case, we are 96 hundredths, almost 1, almost to 1, okay? Now, let's take a look at our next one here. It says 11 times 12. Oh, my goodness. Do you remember 11 times 12? Well, if you remember 10 times 12, it's just 12 more, right? So we're at 132. And again, remember your old decimals hanging out there at the end until you decide to move it. And we got to move it here. Got to move it. By the way, you say, well, Ernie, what about that 11? What are we going to do with that 11? Well, what are we going to do with that 11? Well, let's find out. How about a decimal at the end of it? Because that's where it is if you don't see a decimal. You put it at the end of your number. Remember that. Simple facts. And there are no places to the right, so we have no places to shift. But we do have 2 places here on the 12 that are to the right of the decimal. So we'll count 2 places. How about it? 1, 2, and it looks like our final answer is 1 and 32 hundredths. As many of you like to call that 1.32 or 1.32. Sometimes that comes out of our mouths. But it is 32 hundredths attached to 1. A little bit bigger than 1. More than a whole, and a little bit left over. In this case, 32 hundredths. And you know what? 32 hundredths is almost 1/3. Almost 1/3. Not quite. Getting close. Getting close there. All right, that 1/3 is kind of a funky decimal, isn't it? It kind of repeats itself when it gets to 3, 3, 3, 3, 3, and go on and on and on. I digress. I'm sorry. We're about multiplication day, right? So let's see our next set. Let's see if we can work through these pretty quickly, mental math style, all right? And even to do the decimal counting in your head, I think everyone in here can add 3 and 1. And everyone who's watching also, I know I can add 3 plus 1 most of the time. I will get 4, all right? And speaking, you said, why did you say 3 plus 1? Because we have 1, 2, 3 places here and 1 more there. So we're going to worry about moving that decimal 1, 2, 3, 4. 4 places, all right? Now, you got it. 12 times 8, dear friends, it's 96. And remember, we got to move that decimal place from here out 4 times. I'm not even going to mark them this time. I'm just going to do 1, 2, 3, 4. I need, let's mark it. You said I wasn't going to do it, I know. But let's put them in there. 2 zeros go in there because we've got 1 place, gets you between the 9 and the 6. 2 places get you between 0 and 9, and you need 2 more. So keep moving it. Final answer with the decimal is 2 zeros and a 96. Now, folks, that means 96, not thousandths, but 10,000ths place. Remember, tenths, hundredths, thousandths, and 10,000ths. So that's pretty small. That's pretty small, all right? That's not even 1% when you look at changing that decimal back to a percent. Now, if you got 0.01 or 1/100th, that makes 1%. So this is still a little shy of that, all right? So it gives you kind of an idea. How small is that decimal? Kind of small, isn't it? Well, let's take a look at this next one here. It looks a little bit larger to me. We're going to take, this time, 12 times 6. Times table time, 72, correct? Everybody got that? And our decimal, we just have to move it one place. So we're going to start here, and we're going to put it right between the 7 and the 2 because that's where it goes. Remember, 12 does not have a decimal per se, so we can put it at the end, but that means there's no places to make it move. No places to move on it. And you have it. How about our last one here? Go for it. 12 times 7 is the first thing we want to talk about. 84. And count your decimal places. 1, 2, 3. 1, 2, 3. So we've got to start with the 4 here. To the right of the 4, we're going to move it 1, 2, and 1 more. So we are going to end up with a 0 in front of that, and there's your final decimal place. So those are your answers. If you know your multiplication tables of 12, these were easy problems you could do in your head. If you know your rules for counting off decimals, you can do it in your head. You can do it in your head. So again, we're killing, hey, you say 2 birds with 1 stone here. We're working on decimals, but we're also getting you through some multiplication tables. So, hey, what better way to spend an afternoon on T and Learn Mathline? Learning 2 things at one time. How about it? Not bad, not bad. So let's see what we've got coming our next problem to make us learn even something else. Perhaps you say, Ernie, you're working us today. I sure am. Let's take a look at this one. Let's take a look at this one and see how well we can do this thing in a mental fashion. Now, I want you to notice we have 3 multiplications going on here. And we have a plus and a minus. Now remember good old Aunt Sally. That was the addition subtraction. My dear Aunt Sally says we multiply and divide before we add or subtract. All right? So where we're going to begin, everybody hang with me on this. We're going to multiply. Notice I underlined them. You say, well, Ernie, how do you know that? Because it's like there's an imaginary parenthesis telling us to do that first. It's just what we learned in our order of operations. So again, another review moment here, right? Everybody nod your head with me. Yes, Ernie, we got you. We got you. All right. Let's multiply. See what we've got. 12 times 7, we got that one under our belts. It's going to be an 84. Count your places. 1, 2, 3. So we got to move 1, 2. Uh-oh, need a 0. There you are. Everybody got it? Everybody good? All right, now let's play the next round here. Let's play the next round. We're going to take, how about it? We're going to take, you see it, 12 times 9. Bumps up, actually bumps up quite a bit, isn't it? It's going to be what? 108. You got it? 108. And we have, again, 3 decimal places, so put that decimal right there. And then finally, we got to subtract something here. What is 12 times 6? It's going to be 72. Remember that? 6 feet, 72 inches? Think about height. Usually guys' heights. Don't see many women at 6 feet, but those who are, they're amazing. All right? Now, what do we got here? 1, 2, 3 places. There's your decimal. There's your decimal. Remember, you've got to have a 0 to fill that in. So now it's a matter of let's do a little bit of mental math. Now, some of you say, Ernie, can we get the calculator on this? What do you think, guys? Let's try it. Since this is a back to the basics week, let's see if we can't do it without, and we'll check with the calculator. Got it? All right. So first off, we're going to work this thing left to right. Now, you know my dear Aunt Sally says multiplication, division, they're equal. Now, just because M came before D with my dear does not mean it works that way, all right? Whatever comes first, multiplication and division, we work it left to right, okay? Doesn't matter. Same thing here. So happened addition came first, but had the subtraction been there first, we would have done that, then we would add, okay? So in other words, we don't really jump through this thing, jump away from it. We're going to put these two together. From best I can tell, that's going to give us, looks like, y'all with me out there? 192 thousandths, all right? Line those things up. Remember now, you said, well, Ernie, you didn't count off. We don't when we add, remember, we just line them up. And that gives us what we have, all right? There's no changing of the decimal places here. Line them up, all right? Now we're going to subtract this, 72 thousandths. Not 72 hundredths, but thousandths. Remember, folks, got that 0 there, so you got to think about it. Time to subtract. I think this is not so hard to subtract, is it? How about it? It looks like we've got 120. Now, some of you are going like, could we say 12 hundredths? Sure we could. That's 120 thousandths right now. But we can make that go to 12 hundredths. The 0, it can go away. It's able to go away. That's the way it works with decimals. Now, if it had been between the decimal and the 1, it could not go away. All right? We would be having to keep it. But the way it is, it's at the end, life is good. Now, like I said, let's check this thing on the calculator also. And I'm going to tell you something. There's a nice thing about these calculators. They will do a lot of good things for us. We can get there. Thank you, guys. Appreciate it. We've got that. Now we're going to put a plus. You say, Ernie, you mean you're not going to do them individually? No, this calculator is pretty nice. It will allow us to do a lot of operations at one time. And you know what? It knows about my dear Aunt Sally. It knows which order of operations to deal with. All right? Now we'll have a subtraction symbol in there. And we got 6/10 times 12 hundredths. And, you know, we did those mental math. I think we did right. Let's hit a button and say enter and hope, hope, hope. Yes, it did. Gave us 12 hundredths out of there, or 120 thousandths, how we got it. All right. So there you go, folks. That's, again, powerful brain. No, we were able to do that without any trouble. You just look at those numbers and you work them through, okay? You didn't have to take that old calculator or computer there, but you know what? They're nice to have to check. They're nice to have us check off. So anyway, that's our little technology moment there. Let's go to a few more things that we've got going. You notice in these little videos, we get a lot of things accomplished basically on the premise we're going to talk about multiplying by 12. Well, this time we're going to talk about 9 times some number gives us 108. Now, you can go to a calculator and figure that out, or you can say, hey, Ernie, I got it. 12 times 9 is going to do it. Exactly. Because we're looking for, by the way, what does this mean, everybody out there? Some of you just may be tuning in for the first time this week and you want to know, what does that mean? It means 9 times some number, I don't know what it is going to give me 108. Now, it so happens it's going to come out even. That doesn't always happen, but with you got 9 and 108, it comes out even. Because we're thinking, what in our times tables, what number times 9 is going to give us that 108? Well, it's 12. It's 12. If you know your times tables, that one's an easy one. If not, you can still go and divide 9 into 108. It takes a little bit longer, doesn't it? Because you got to do long division, or you got to tap it in on the calculator. Know it up here. The brain has the numbers that's ready to go for you. So there you go. Oh, by the way, the answer? Let's go for it. X equals, 12. Yeah, today's the show all about the 12s. Dozens, all right? Okay, now let's throw the 12 in the position next to the x. We call that the coefficient of x. So in other words, we want to say 12 times some number gives us 84. Once again, panic? Oh, no, don't panic. Go to your times tables. Think about it. What number times 12 is going to make that work? In other words, how many dozens give us 84? Well, okay, maybe even. How many feet would give us 84 inches? You could look at it that way, all right? Let's put it into things you understand, things that you notice, all right? But how many 12s are going to give us 84? Lots of ways that we can express what this is telling us, all right? Now, easy way to figure it out is it's 7, right? Because 7 times 12, that's going to give you 84. For those of you who didn't remember, 12 times 7 was 84, you can divide it right there, long division style. It goes 7 times. It works out beautifully. So there you have it. Or, yeah, I know. You can go to the calculator, right? So, anyhow, the 12s, they are important. They are important to us. And again, as I said, using dozens, using inches and feet, the relationship, 12 inches make a foot, those kind of things become, why do we need to know about dozens? It's a great measurement. A dozen eggs. A dozen and a half eggs. Well, what's a dozen and a half eggs? Well, you have a dozen, which is 12. Half a dozen will be half of 12. 18 eggs, all right? Check your stores. You buy both ways. And sometimes you buy up to 2 dozens or multiple dozens, all right? You can buy a gross of eggs. That's 144, and by the way, 12 doesn't. I digress, right? Let's get back to some of our multiplication. Actually, we were multiplying right there when you run through those real quickly. Let's take a look at this next little problem. I mentioned feet and inches, all right? How many inches are in 9 feet? And this is a conversion problem. It's a conversion problem. Now, you got to think about it. I have people say, well, do we divide 12 into 9 or do we multiply 12 times 9? What do you think? What do you think out there? You've tuned in this afternoon. What do you think, folks? Ask yourselves. Well, I'm looking for inches, and each foot, about like that, divides into 12 of those inches, all right? So if I've got 9 of these things, guess what I've got to do? I've got to multiply. So in this case, I'm going to pick up 9 times, and how many I just say? We got how many in this little space here between my, between my ears, not quite, between my hands here, my palms and stuff. How about it? There's, about 12 inches there. That's a foot. So we're going to use our, guess what? Multiplication tables, right? Boom, boom, boom. What is 9 times 12 going to give us? Gives us 108. And by the way, those are inches. Those are inches. Now, I'm going to go one little notch here because I'm going to take this just a little bit of notch higher for some of our students who say, I figured that out pretty quick. I'm going to show you also a nice little way that you can make your units work. You say, what do you mean by units? Start with 9 feet times 12 inches per foot. And you go like, whoa, Ernie, what does that mean? Well, that means we're going to multiply, and we'll just put this thing over as a fraction. Put this thing over 1, all right? And the feet will cancel out because they're the units there. Notice how they cancel out, just like a little variable there. And we've got 9 times 12, which is 108. Look what's left over, folks. The IN, inches. So those are what we call dimensional analysis. Well, that's fancy, isn't it, for saying, let's convert from feet to inches. All right, but that's what dimensional analysis is all about. So if you hear that word, those you're in Algebra 1, Algebra 2, you go like, ooh, how about that? How about that? You go backwards and forwards with those, all right? Speaking of going backwards, let's take a look at our next problem. Look at our next problem here. It says, how many feet are in 84 inches? And again, I've chosen numbers that I want you to recognize because they're your multiplication tables that we've worked with. I'm not going to give you 80 as an answer to 80 here where you've got to have a fraction or something. I'm wanting us to go basically, these things go in evenly, all right? So how many feet are in inches? Well, guess what we just did? We multiplied to go from what? Feet to inches. Now we're coming from what? Inches back to feet. So we've got to reverse the process. We want to know how many feet are there in 6 inches? So how about this one? 12. I'll put F for number of feet equals 84. Now this one we just had something like that, a little algebra problem, just a second ago, a little pre-algebra moment. So 12 times what number? Isn't that right? Or 12 times what number of feet will give me 84 inches? And 12 feet does equal. Well, no. 12 times how many feet? 12 times how many feet? 12 times 7 gives us 84 inches. So that's the number. F equal, remember, the number of feet. How many feet are in there? And in this case, we got 7 of them. 7 feet give us 84 inches. And you use a ruler all the time in life. So practical, very practical application going on there for you, all right? Now, one last moment here. This is one I love. This is one I love because many of my geometry students, when I teach geometry, don't quite catch on to this. So let's take a look at this last one real quickly. This is how many square inches are in a square foot? Now, a square foot basically happens when you take 1 foot times 1 foot, you get 1 square foot. How about that? All right. So let's go back here. How many inches are in 1 foot? I get 12 of them. We'll put the I in for inches. Times 12 inches. Oh my goodness, everybody got that one down? I told you it's such a great one to be able to do to square 12. Square 12, here we go. It gives us 144, and I'll abbreviate square inches. There we go. And that comes from what? 12 times 12, right? Gives you 144. Now, we've had fun this week. I hope you have anyway. And I know for some of you have said that, wow, that was awful easy, Ernie. A lot of those things, I'm glad it was easy for a lot of you. But I hope that some of you learned a few more times tables from watching the show this week. And you know what? We're here to help. That's what summer school's about. Get some remediation, give you a little bit of a boost so that next year in your math classes, life will be easier. You're going to enjoy it a lot more too. It's going to be a lot more entertaining. And it's always kind of nice to say, hey, I know that. I know that. And be sure to tell your friends that we're doing summer school here on T&N Learn Mathline also. If you've been tuned in watching, we've got some great episodes coming up here just to give us remediation through the summer. What we do, throw in some algebra on down the road, and some of you are going like, yes. And a little geometry maybe. Wow, the sky is the limit. But we'll see where we go, all right? But thanks for tuning in this afternoon. More of those basics. Cheaper by the dozen. Oh, yes. We'll see you again tomorrow.